The fourth experiment in the computer aided engineering syllabus of Pune University is beam element nonlinear buckling analysis. So we are going to perform this experiment with the open source software Lisa 8.0. So first we will go through the example that we are going to solve with the Lisa 8.0. So a beam with three different square cross section. The left and right cross sectional area is 225 mm square and the middle cross sectional area is 100 mm square is shown in the following figure. It is fixed at the left end and force of 5000 Newton is applied at the free end. Bending moment at the free end is 1000 Newton millimeter. Find the displacement magnitude for three modes. So take shift point as 0.2. So this value you will require in the Lisa software. So as we have taken the three different cross sectional area, so that means we have applied the geometrical nonlinearity and we are going to assign the material with different Young's modulus. So material nonlinearity we are going to apply. So now, so the length of the first element is 300 mm, 400 and 300 mm. So I will new. So first analysis, static 3D, right click on it, click on edit, select the 2D, then buckling of 2D beam. So number of modes I am going to select here 3 and the shift point non-zero value which is 0.2. Click on OK. So now here I will click on the nodes, new node, the first node at 0, 0, 0, add. The length of the first element is 300 mm. So along x-axis minus 300. The length of the second element is 400. So along x-axis minus 700. And the third element is having length 300. So total minus 1000. Add. So you can click on this screen and zoom out with the help of middle mouse button. So now you can clearly see all the four nodes, node number 1, 2, 3, 4. So now I will click on this new element, select this line beam element, then select the first two nodes, node number 1, node number 2. After that, node number 2, node number 3, second element. Node number 3, node number 4, third element. Click on close. So now you have created the three elements. Here in the left panel you can see the total number of elements are 3. So now I will select this tool, select elements, and I will click on the first element. So click on the first element as you can see in the blue color, then right click on it, then add elements to new component. So here, so this one element is separated from the remaining two elements. So I will repeat this procedure for the remaining two elements. I will separate it. So click on this second element, right click, add elements to, so add element to new component. So again select this third element, right click and add elements to new component. So now all these three elements are separated. Okay, so select this first element, then right click, then assign new material. So here in the geometric, select the general section. The cross sectional area of the first element is 225, a square cross sectional area, and the formula for moment of inertia for the square cross section is a raised to the power 4 upon 12, so which comes out to be 4220. So in the mechanical, I will select isotropic and I will enter the Young's modulus as 180 Newton per millimeter square. Click on close. Now I will select on the second element, right click, assign new material. The second element, which is the middle element, select the general section. The cross sectional area in the example is given as 100 millimeter square, and with reference to this 100 millimeter square, the formula for moment of inertia of the square cross section is a raised to the power 4 upon 12, so which comes out to be 834. So in the mechanical properties, I will select isotropic and here I will take Young's modulus as 200. Click on close. So on the third component, right click, assign new material, general section. In the geometric tab, cross sectional area is 225. So with reference to this cross sectional area or square cross section, the moment of inertia is 4220. So in the mechanical, isotropic, Young's modulus as 180. Click on close. Now we have got three elements with different cross sectional area and different Young's modulus. So non-linear geometry and non-linear material properties. So now I will apply the boundary conditions, constraints. The left end is fixed one. So first I will select these nodes, then select the extreme left node, then select this face, then in the loads and constraint, right click, new fixed support, create from current selection, OK. So now select these nodes, select the extreme right node, then in the loads and constraints, new force. Okay. So in the downward direction, 5000 Newton force is acting, so minus sign, minus 5000. OK. Again select nodes, this tool, then select the extreme right node, then in the loads and constraint, right click, then new moment. So along x-axis the moment is 1000 Newton millimeter. So click on OK. So here you can see the moment symbol. So now I will right click on the solution and solve. So now here you can see the results. So for the mode 1, you can check the displacement magnitude, okay, which is maximum value is 29.21. For the mode 2, the maximum displacement magnitude is 3.297, and for mode 3, the maximum value is 0.7526 with buckling factor 9.0 into 10 raised to the power 14. You can see this entire result in the tabular format. Click on all the three nodes. Here you can select all the option and click on update. So the buckling factor and the displacement values are along XYZ axis are provided for all the nodes. Okay. So click on solution and you can animate it with the default values. Okay. So this way you can see the animation. So next you can change the force from minus 5000 Newton to 5000 Newton in the reverse direction, in the upward direction. Click on OK, right click solution, solve. Okay. Now you can check the for mode 1 The displacement magnitude is 4.924 with the buckling factor 1.11 into 10 raised to the power 13. For mode 2 it is 1.625 with buckling factor 4.5 into 10 raised to the power 14. So again here you can right click on the solution and click on animation button. With the default values you can play the animation. So here you can see the difference when you have changed the force from minus 5000 Newton along y-axis to 5000 Newton in the upward direction. So click on close. So I hope that you have understood this experiment. Okay, thank you very much.